Okay, so here's your Tyro79. I've already cut the tape, so let's open it up. Now I'd like to give a brief overview of all the parts that you've got in here, just to help you understand. So this here is our bottom plate. So obviously your 4 motors mount, and then your flight controller stack goes in the middle here. It's so cute and little, but that makes it really great. What we want to do, got some props. We probably won't use these, the 4 blades aren't much use. Now we get into the good parts. Got some spanners, which is good. Okay, so this little board here is your flight controller. Okay, so this flight controller has got a lot of stuff on a very tiny board. So it's what we call a 20 by 20 mil stack. A lot of stuff that you find these days is actually a 30 by 30 mil stack for 5-inch and bigger quads. But they make them smaller for these little 3 inches so that things are lighter. This is actually an all-in-one flight controller. Sometimes that means that it has a PDB or an ESC as well. But this one, it just means that it's a flight controller and it's got OSD and a few other little features. Okay, so what you'll notice right here is this is our F4 flight controller chip. This is actually the main processor on the unit. This here is our little gyro. And on the underside, we've got power regulation and OSD chips. But it's a very simple board really for what it does. And the output is actually quite amazing. Next up, what we've got here is the 4-in-1 ESC. Traditionally, you'd have 4 single ESCs and they would have positive ground and a signal wire going to each ESC. But because this is such a small build, we've got the 4-in-1 ESC that mounts directly below your flight controller in a stack configuration. And then we've got this one plug here which will have a 6-pin wire that goes to the flight controller, and those 6 pins will carry 5 volts ground and 4 signal wires for each of your ESCs. And then each motor has got 3 wires that come on there because these are 3-phase brushless motors. These little black pieces on the board here are actually the MOSFETs, and they are what switch the poles on your motors to make them spin. You notice this ESC comes with a capacitor pre-installed. That's actually pretty important. Power filtering with an ESC is one of the most important things, and it can actually interrupt radio signal and give you a bit of video interference as well. That's because at full power, these little chips are switching between from side to side, and that gives you voltage spikes and voltage sags. Next here we've got the video transmitter. This one is very specific to any sort of quad where you've got analog video. So I use it with all of my race drones because there's very low latency, although you are stuck with a 480p type quality. But the biggest advantage of analog for video signal is that if the signal starts to drop out, you can still see it. Sometimes it'll be black and white or it'll have some lines, but you don't lose signal completely, and that gives you a warning that you need to turn around and start heading back in your direction. Which is very handy if you're flying something beyond line of sight. So this one here might actually have smart audio capability, which yes it does. So it's got a data pin. So smart audio is named smart audio because traditionally it was using the actual audio channel into the VTX. What that does is that allows us to control this VTX with the flight controller through the use of a signal UART. And that control enables us to change VTX channels, like frequencies, from around 5600 MHz to 5900 MHz, and output power. While we're doing electrical components, let's have a look at this happy model part that we got outside of the Tyro box. The reason we get this is because we get the Tyro as a kit without the transmitter, which is this hand controller, the FSI6. So that means that they don't have a matching receiver to go to the flight controller to match that transmitter. So we had to order this separately. So what we've got here is what we call a Fly 14 Plus, which is quite a new type model on the market. It's a very tiny receiver. You've got your two antennas here, which ideally are mounted 90 degrees from each other. You'll see how we mount them when we actually do the quad build. And generally this only has your 3 wires, which is 5 volt, ground, and signal. Signal here will be S bus or I bus, whatever we set. We will run I bus though, because it's a little bit superior. And one of the special things about this receiver is that it has RSSI readout already set up on one of the channels. This means that it can tell the flight controller when it's losing signal, and even better, it can actually put the signal level on our OSD display. Here we have our little brushless motors. So these are Earchin branded for the Tyro, and these are a 1607 2800 kV rating motor. So that means that the stator inside of here has a diameter of 16 millimeters and a height of 7 millimeters. This is actually a very big motor for this size quad. It makes it go quite quick and is apparently pretty exhilarating to fly, but we'll see when we get to that. You'll also note that these motors have, 2 of them have a silver nut and 2 of them have a black nut. This is because these are counter-rotating motors. Now you may encounter this with drones. A lot of my high-end drones with very expensive motors actually don't have the counterclockwise one. That's because a lot of them are made in minimal quantities, and it's a lot of extra work to make a second die for the counter-rotating bell. But nonetheless, these ones here, because they're made in large quantities, have counter-rotating and standard rotating prop threads. So the difference here is that this is the counter-rotating thread, which means that normally lefty loosey, righty tighty, but here it's the opposite. So you turn it right to undo and left to do up, whereas this one is the other way. The purpose of this is so that if your props come into contact with something, they will automatically do up instead of undo. And this is actually very common with the DJI quads before they went to the clip-on, clip-off propellers. Here we've got a little wire kit. This plug here is actually called an XT30. A lot of the bigger quads that we run have XT60, and my really big ones have XT90. That number refers to the constant amount of amps that it is rated to flow. So this one's rated for 30 amps, and it comes with some little wire. The rest of these wires here are for hooking up our receiver, so we'll see that soon. The last electronic piece we have here is the little camera. This is just a small CCD lens with a 2.1 CCD camera with a 2.1 millimeter lens. Runs off of 5 volt. It's very basic. I wouldn't recommend trying to fly with a camera like this for a long time, but it will get you in the air. We've got an assortment of screws, so we will sort through these and figure out which ones need to go where soon. The Tyro's side plates, these make it look really cool. Sorted cable ties, which is great that that's included. A battery strap to hold the batteries on. And the side plates that go with those aluminium pieces I was just showing you. And some little spares. And that empties out the Tyro box here. Okay, so here we've got all of our screw types. So here we've got 3 small screws. And they have a Phillips head. Then we have the smallest size hex head screws, a medium size hex head screw that there is the most of, and then 3 of a little bit longer hex head screw. We've also got some standoffs and some rubber mounted standoffs. Okay, it is time to start assembly. So we've got our frame. We're going to get a medium length hex head screw and an Allen key to fit it, which is a 1.5 millimeter. We're going to put the screw through one of these 4 holes in the middle here of the bottom plate. And we're going to get one of these plastic standoffs and screw on top of it. And repeat that for all 4. Okay, now we're going to start mocking up the build. So we've got the ESC here. Now there's a little white arrow on the top of this. I don't know if you'll be able to see it, just behind the plug here. So that means that the plug goes on the top and the white arrow goes to the front, which gets our board orientation set up. We aren't going to solder on this just yet. We're going to mock up the full build and then we'll go from there with the soldering. Okay, so I've had a look and unfortunately my kit seems to be missing one of these plastic standoffs, but that's okay because on a quad this small, you really don't need all 4 anyway. So we're just going to run the 3. But if you do have the 6 plastic standoffs in your kit, run 4 on the bottom here. And the other 2 will be at the top for the VTX. I know the VTX has 4 holes, but it's also a very lightweight board, so it doesn't need all 4. Going on top of this, on top of this ESC, we're going to have the 4 rubber standoffs. These are for vibration isolation for your flight controller. And you'll notice that you still have a bit of movement in here, up and down. This is just because these little standoffs are very long, so we'll have to trim them up with a knife or some cutters. But for the purpose of a test fit, it doesn't really matter. Now we get to our little flight controller here. It's got a little white arrow facing forwards. That's got to line up with a little white arrow facing forwards on our ESC. And we smack that on there. And then we've got the 2 layers of our stack set up. And then on top of this, we're going to have 1 nut here on our flight controller on the corner that isn't going to have a standoff. But we won't put that on, we'll just put on the 2 other standoffs. Got 1 standoff here and 1 standoff here. That mounts our flight controller family. And then we will have the the VTX sitting on top of that. And that there completes our stack. So everything seems to fit up okay. We're definitely going to have to cut down those standoffs a little bit because you can see that this is very close to the top plate. So once we take 3 or 4 millimeters off each of those standoffs, we should be just right. So let's pull it back apart now and get ready to do a little bit of soldering. So if we just look here, we can see that we've got 1, 2, 3, 4, 5 threads sticking out of the bottom of these standoffs where they don't screw all the way on. That's the same all the way around. So we're just going to unscrew them and then take off this ESC so it doesn't get damaged. And I'm going to use a knife. You can use knife or just some side cutter pliers like these. I prefer to use the knife, it just leaves a cleaner cut. We're going to take about 6 threads off of here, off of each one. Okay, now we can get ready to put our ESC on and solder it up for good. So we'll just screw one of these standoffs on for now to keep things steady. So the first thing that we have to solder is this XT30 pigtail onto the ESC. So we can see a little plus and minus. All we need to do, solder the plus on there and the minus on there. It should be pretty straightforward, but if you haven't done any soldering before, this is a good time to start getting some practice. Now, without going too much in depth, this is my soldering iron. It's got a digital temperature control. So I have it set to about 360 degrees normally. If you've got a soldering iron with just a dial, if it's a 50 or 60 watt soldering iron, anywhere around the 3/4 mark is normally pretty good. And then I use a sponge like this one here, and you need to keep the soldering iron tip clean, just giving it a wipe on the wet sponge, and you can see the soldering iron tip is nice and shiny now. Now I've got a little bit of solder here just in case I need it, but I don't think I will. I'm just going to tin the tip of my iron with the solder. Tinning is just putting a little bit of solder on there so that it can contact with the other solder Now, because this capacitor is already soldered on, we've got a bit of solder on these pads, which is great. We should be able to just melt this straight on. But it also means we need to be worried about the capacitor falling off. But since both legs are joined on, I think we'll be right. Here I have some solder paste. So we'll just grab a little bit of this and just actually dip these wires in it so that they've got a little bit on there. Just be careful, this stuff is a little bit acidic if you are using it. Still at 360 degrees. Put this on there. And there we go. Starts to solder right away. You want to have melted down into the pad. And that looks really good. So while we're going, we'll just do this other positive one. And that's soldered straight on. Now that we've got power to the ESC, we need to start working on our motors. Okay, now we need to connect these motors to this ESC. Before we can get our wire length perfect, we actually need to screw on the motors. Now this is going to be the permanent fixing. So what we'll do is first we'll figure out which way it needs to be. So I'll put an image on the screen that shows the layout of the quad with the arrow forwards and your red and black. Okay, so our motor direction on the front left is clockwise. Now, if we have a look at this other quad that I've got here, it's also got the counter rotating motors, and on the front left we have a black nut, and on here we've got the other color, which on this one is red. Now the reason for this is with the motor spinning this direction and the prop hits something, it needs to spin the nut counterclockwise to do it up and keep it tight. So we'll go from that to mean that this motor has to go here, this motor goes here, and then the opposite sides on the back. I'll screw these on with these middle length hex screws now. So yeah, let's get them on. Okay, there we go. All four motors are attached. Now, normally I would twist these wires together to reduce electromagnetic interference, which is quite a big deal on a drone. But because these wires are a bit stiff and they're on the shorter side, we're just going to run them straight. Now, you can run these however you want. If you want to, you can run them straight in and off the edge. But for the sake of being tidy, I'm going to run mine along and around the standoff and then solder backwards onto these pads like that. So that'll give us a nice tidy appearance of all of the wires running along the arms and then poking out. Once it's together from the outside, you probably won't even really see them much, which will be good. Now, it is important to straighten these wires out nice and straight before you do any soldering. Once you start to solder on them, they tend to hold their shape a little bit better. But before we do any soldering on there, we actually need to tin all of the pads on this board. This is where having a little bit of flux can be important, but if you've got a nice rosin core solder, that we will probably make sure that you have, just putting fresh solder on there, you don't really need the flux. But I'm going to put just a touch of flux on each of these pads. Now I'm going to get my soldering iron, wait for it to heat up. It's already clean from when we cleaned it before, but if yours isn't clean, obviously clean it again. And we're going to go around. And the aim of tinning these pads is just to get a little bit of solder on each pad. It doesn't need to be a big ball, but the pad needs to change from gold to silver. And there you go, my pads are tinned all around, and you can probably see that they're all silver now. Turn your iron off while you're not using it. Now, this is where it's probably nice to have a pair of pliers, something like this, or tweezers are a good option too. Okay, I've got my first wire sitting here how I want it. I've left the other two hanging up a little bit just so that I can get this inside one done. And it's just a little bit too long, so I'm going to grab my snips and snip just a little bit off the end. This means that we no longer have a tinned part of the wire on the end, which it comes tinned. Which means we now need to cut back the shielding. I'm going to use my knife for this. Try and cut back the shielding the shortest possible because this shielding shrinks back a little bit when you heat it up. Now, the same as the pads, we actually need to tin these wires. So the same process with the soldering iron again. You just need to get solder onto the wire. Okay, they all tinned up very nicely. So the next step is to solder them onto the board. I'm just going to move these outside two out of the way and get the inside one in here. And I'm going to grab it with my pliers at a certain angle so we can run it straight around here and solder it on like that. And then we will repeat that process for the other two, sorry. And this here is what your finished product should look like. Shielding all the way up, and on this camera you can actually see the soldering as well. Looks quite good. I do like putting it around the standoff like that. And then we've got this wire here running all the way along, and I've got it just tucked up inside there so that we've got a little bit of leeway for room in case this motor was to come off or something was to get caught on there. This has a little bit of stretch in it, which is very important. Okay, so here's what the ESC wires look like when they come out. Now, you want to check very closely for shorts around here. Make sure you haven't dropped a solder blob on the ESC itself. But mine's looking pretty good at this point. I've got all of the wires tucked up under here, nice and flat. At the end we might put a cable tie around the arm here just to hold things in place so that these wires don't get flicked up by anything. But it's coming together quite nicely. So next what we're going to do is put on this flight controller. So that goes next on the stack, and these are the arrows that I'm talking about here. So this arrow needs to go to the front of the quad with the one on the ESC right there. So we've got to put that on there. And then next up we've got this cable here to run from the ESC to the flight controller. So this is the cable that's got 4 different colors and then a red and black on each side. Now we're lucky with this kit that everything is pretty well plug and play. So this plugs in on the bottom, and you want to put the little ridges on the plug up. That's not the side where you can see the contacts. That's the side where there's no contacts and there's little ridges. You want to put that side up and plug it in. You may have to shove the ESC wires, motor wires, a little bit out of the way to get it plugged in nice and tight, just because the little prongs on the side of this plug do stick out a fair amount. Now, the next part is this plug here. The other end of this cable has to plug into the flight controller. Okay, so this next wire here has to plug into the flight controller. The thing is, we don't want this big bunch sticking out the front here. So, what I would recommend that you do is bend this wire up and flatten it off very neatly. And then we want to bend it back out. We want to put a little bit of an S-bend in the middle, like so. And then we want to bend the other way on the other end of this wire. This should keep all of the wire actually contained. So we'll plug that in before we put the board on. Same way with the little ridges up to the top. Now we press the board on. Try to make sure that there's no tension holding it up, which I do have a little bit. but a quick wriggle sorts that out. Okay, so now that's sitting there, we're going to put the next layer of standoffs on. So we've got the two on diagonally opposite corners here. These are going to go on top of there to hold the VTX. Actually, I've got enough to run 3, depending on how you laid out the bottom. I think we might get a few more standoffs for the kit, just so that you can run proper standoffs all around. I think that's pretty necessary, really. So I'm going to run a little nut on this corner here to hold things in place. Now you notice that the flight controller isn't very firmly mounted, and that's because we've got these little soft mounts underneath. And it can actually wriggle around quite a bit. And the reason for that is so that we don't get as much noise from vibrations in the motors into the gyro of the flight controller. So this means that we don't have any erratic movements and that the quad generally flies quite smooth. Now on here we've got 3 plugs left and a few solder pads. So if we make any changes to the quad, we can actually modify it with these solder pads. But for now, we're going to use the couple of more wires here that are included. We'll have a look here. We've got the camera left and the VTX left, aside from this receiver that we were going to put on. Now here we've got 2 JST or JR plugs that have a small JST XH plug on the other end. Now this Fly 14 receiver and the flight controller both have the same JST XH plug. So we'll order some wires that have this plug on the same end so that you can plug and play that. And we'll probably do the same with this VTX, because at the moment you'll notice it's only got 3 wires, which is power, ground, and video signals. Okay, so we had to take it back a step or so. I did some investigating on the wiring. So I've just realized that obviously I'm still putting together this kit. I'm going to have to order us a cable that has got these plugs on each end. This is for our Fly 14 receiver. That's okay, I just did some soldering and made this cable, but I'll make sure that we have one for the final kit. And then for this VTX, I actually got another wire that I had laying around and pinned it into this connector, and I didn't have a pin both ends, so I soldered it onto the data port on the other side of this VTX. Now the purpose of that is so that we can have the smart audio functionality that I mentioned earlier. So we will also get one of these cables pre-made so that you can plug and play it nice and easily, or maybe we have to do some repinning, but we'll see what happens there. So now I'm going to go ahead and reinstall my flight controller. I just removed it to check some wiring on the back here. Now I've got a camera here. So the camera has 2 different plugs on each end. Now you want the one that's got the little nipple at the end of the plug, not the one with the little ridges at the end of the plug. You'll see that the little nipple lines up with the little hole on the camera here, and that plug fits in. And then this one also with the ridges, much like the ESC connection, plugs into the flight controller right here. So I'm going to plug that in now, but I'm actually going to unplug the camera because we want to be able to mount that up a bit easier later. Okay, so back to where we were with its VTX. So now that I've got the extra wire in there and the plugs, I plugged the plug into here when I soldered this extra wire on. Okay, so I'm just going to jump in here quickly. So we couldn't actually get the right cable made for this VTX, but because this is a line of sight unit, unless you get yourself some goggles, you really don't need this functionality, so we've thought that it's probably okay. So if you do want to set up this and use FPV and learn how to use the smart audio feature, which enables you to change channels and things without opening it up and pressing buttons, just let me know. You can contact me through Mike Maloof. I'm sure I'll give you my contact details, or I might actually put my contact details in the description. We can plug this plug into the flight controller here, and you'll see a little teeny writing on there that says VTX and here that says cam. So that's how we know which one's which. And we want to make this with this little antenna headed straight out the back. I'm tempted to go around like this so that it's not quite as long, but I don't think we'll be able to protrude past this frame. And this is the kind of thing that you need to think about when you're putting together one of these. So here, that's going to be inside the frame, which obviously is not good for signal. So we need to run it the other way. So I will run it, the wires underneath like so. And that looks nice and tidy. And then we'll screw these screws down on top just to hold it in place. Okay, so that's screwed on. This is our stack complete. The only thing we've got left to mount up is this receiver. So in doing that, we're going to have to think about where we're going to mount these antennas. So what I normally do for antennas is I get one of these cable ties. And we'll wrap this cable tie around the arm underneath the motor. Like so. And we'll get some heat shrink, which will be included in your kit. And we'll mount the receiver back here somewhere, and we'll heat shrink this little part of the aerial that's clear at the end to the cable tie, and then obviously snip off the cable tie where necessary. But before we go ahead and do this part, we're just going to finish off this VTX. Now, this little connector here is actually a little bit loose, and it's very important that we keep good video signal. So what I'm going to do is I'm going to get a little bit of hot glue and melt onto there. Okay, so we've got a little bit of hot glue here, nice and hot. Just going to melt that around that antenna. Okay, we'll plug in this wire with the 3 wires and the same plug on each end into our receiver, and I'm just going to plug that into the flight controller board. Hey guys, it's Dave from the future here, and I just want to give you a quick overview on some wiring changes I've made to this receiver just to make everything work correctly. So there was a bit of a lack of documentation on this flight controller, and we can't actually hook it into this socket here that I show in the video. So I've just popped in now in the clip, and I'll update you here, and then I'll update you in the setup. There's not really much to change, but basically the little cable that you get that comes from, it comes in the box with the Fly 14 receiver, in the packet. It's got a plug like this on one end, and it's got the little plug that comes in here on the other end. So what you need to do is cut off this black plug, right? And then you solder on the wires onto the flight controller, and I'll give you a close-up of those in this next video. But yeah, so here you solder the power and the ground to these little spots. This is actually set up for the LED, but that's okay to use it for this as well. It's just a 5-volt and ground output. And then we've got to solder the yellow wire to up here, and that's an RX port that's available. So yeah, just do it like that, and not how I'm showing here with joining the wires, and continue on, and I'll update you later on. Now, for the next part, we're actually going to start assembling these side plates. Now, I found that in the manual, there's a bit of direction on which screws go where on these parts. Okay, so the next part we need to assemble is these sides. So most of this is done with the shinier, shorter length screws, but it's all depicted in the manual, which I'll put up an image of on the screen right now. So we've got a bit of color coding here which specifies which screws we need for each part. So we've got a few different parts. I'm going to put these little top pieces on first. You'll notice the recess in here, that is actually for the camera, so that needs to go to the inside. So these two will be sandwiched like that. So we'll start with this square piece. Doesn't look to go any particular way. And there we've got a M2x5, which is one of the shinier, shorter length screws. Just going to put all of these in a little bit and get them all mocked up. That way we don't have any fitment problems if one of them is done up tight in the wrong spot. This is actually a very narrow frame. This little single piece, it goes up here. And now that these are somewhat mocked up, we're just going to do them up, but not tight, just until they touch. This is because when we actually screw them to the frame, they're going to need a little bit of movement just to get situated. I notice that the screws do poke out a little bit on the bottom, but that's okay. Okay, so next pieces to go on are these side plates, but we're going to mock them up straight away with this other little piece, which is a VTX antenna mount for an SMA style, which is what I've got here on this quad. It's got an SMA here. That is for a bigger antenna if you want to increase your range, but we will also maybe put our whip antenna through it. So this sits in between the two plates, and then you put this plate on top and line up one of the longer screws. These are the really long ones. There should be only 2 or 3 of them. Okay, there we go. Again, we're not going to do them up tight. Just going to put the other side on so that this antenna bracket is held steady. Alright, just on there soft. Now the rest of the screws in here, which there is 3 on each side, are again going to be our shorter, shiny screws, not the matte ones like we used on the motors. Okay, now that should use all of your shiny screws up. Now if we have a look here, this sits over the top, and we've got to do some juggling with the ESC wires just to make sure that they don't get pinched. And it sits on top of your frame, and look, we've got a little quad. Now, the camera actually mounts inside this piece here as well. So what we might do, just trying to get this camera cable sitting nice, I think we'll plug in the camera and then we'll screw it into the top plate. But before we do that, we need to figure out where we're going to mount this Fly 14 receiver. It's got to go in here somewhere. We mount that antenna just like that. I think we might actually be able to fit the Fly 14 on top of the stack here. Okay, so next thing we're going to do is, included with the receiver was a small amount of heat shrink. So we're going to put that over the receiver. Since I've already got it plugged in, I'll put it over the antenna end. And we can use a heat gun, hot air gun, or a cigarette lighter. I'm just going to use my hot air gun because I've got it here. Okay, so we're going to run this receiver flipped over on top. Now, it's still a very tight fit. So what we're going to do is we're actually going to run the wires underneath the VTX. So I'm just going to unscrew it again. Fold that over. So we've got wires running across there for the VTX. So for this one, we'll run these wires like that. We might actually go underneath the VTX wires because these ones can sit down over here. VTX goes on top like so. Tuck that down nice and neat. And we'll put this VTX back on. Okay, now that this is installed, we just want to cut these standoffs down a little bit because they're a little bit too high. They don't need to be protruding past the screws that much. So there we go, all cut down. And our receiver is now running neatly underneath, straight through there. So we can sit that just on top of here. I'm just going to cut out this heat shrink a little bit to make it fit better. Okay, that's sitting nice. So what I'm thinking is that I will just poke a cable tie through underneath here, making sure that it doesn't go underneath any wires. We want to stick over the top of the wires. Go, like that. And we'll just flip that over here and do this up. Now we won't do this up super tight. We just want to keep this receiver in place in a nice little spot here, just so that it doesn't bounce around and move around. Okay, so that's sitting quite nicely. The cage fits on. It may need a little bit of pressure, but it's pretty good. Now we've got to get these receiver wires, the little antennas, outside of this crack here on the inside of the quad, and we've got to put them on these cable ties. So I'm going to put a cable tie on the other arm as well, so we can do both at the same time. And I'm going to grab the small round heat shrink and cut a piece to length. So it needs to be about that long. I'll cut 2 pieces. Now this can be a little bit tricky at times. We need to feed the heat shrink along this cable tie. It is a tight fit, but that's good because that means that the receiver antennas don't slide. So we're going to slide them inside of there. As we slide on the heat shrink, slide it all the way up. We want to make sure that that entire piece that's clear with the shiny wire at the end is out on the cable tie. And that's sitting quite nice. I'll just do the other side while we're at it. And now that we've got that on there, we can use a cigarette lighter, or I'm going to use my hot air gun just to shrink it. Make sure you do both sides so that it's nice and tight. Okay, that's all good. Now we'll just snip off these pieces a little bit past the antenna, so you can see the shiny bit goes to about 5 millimeters before where I'm cutting. Do the same on this side. Now we have our little antennas made. Now it's good to remember that these are 90 degrees or so apart, which means that at any angle either one of them has pretty good signal, as they're a linear antenna. Now the next thing we need to do is for almost final assembly. So it's easier if we take the lens cap off of the camera, and I had the camera in there for mocking up, but the writing on the camera goes upwards. So now we're going to plug the camera in, and then for the final time we're going to slip this little top plate on, which means we need to put the antenna in, and then we need to pick the camera up and slide the camera in. We just need to sit it in there. We don't need to worry about the screws just yet. Then we need to shuffle this down into place. Don't put too much pressure on until we've got all of the ESC wires or the motor wires sitting nicely. Okay. And now we're going to get our slightly longer matte screws put through the bottom plate into this aluminium piece, and we're just going to mock them in there for now. We won't do them up super tight till we get the camera mounted. We just want to get them sitting in there. Okay, now we have to grab our camera and slide it around and line it up with this little slot here on the side plate. So you can see the little brass hole in the camera. And this is when we get the Phillips head screws, which are even shorter again. And we screw these into that side of the camera there. It'll be good to have a little screwdriver for that. So we can see them just here. It's actually a little bit tight to get in, that one. And now we'll go around the other side, which should be lined up because that side's in. And now we just got to go around and tighten up all of these screws. Now we haven't actually bound the receiver yet, which can be a problem later because we need to press a button on the receiver to bind it. But the advantage of this frame is that we can just undo those 4 screws on the bottom and the whole top section comes off. And now that we've got everything situated, we don't have to worry about doing up and undoing these screws all the time, which is very helpful. So don't forget to tighten up all of the screws. And there you have it, you've built your own mini drone. Now I wouldn't put any props on yet as we've got to do computer setup, and that'll be the next part of this video, but you don't want to have props on for doing any setup on the computer because in the case that the props do accidentally spin up, it can be really dangerous. We don't want anybody getting hurt. But yeah, here's your quad. Okay, so it's the next day now and here's our finished product. It's looking nice and tidy. Now, I think we might be able to get to the bind button here on the receiver, but we'll see about that when it comes. But next up, we've got to start going through some of the other things that are a part of this kit. The first thing that you're going to need when setting up this quad is the ability to charge up our batteries so that we can use the batteries to power the quad while we're setting it up. So this IMAX B6 is what we've chosen for the kit. Chose this because it's a trusted, reliable charger that's been around forever. This one was quite well priced and it also comes with a power supply, and that's one of the most expensive parts of the charger, generally speaking. So yeah, let's open up the box. Okay, so in here we've got a bunch of cables. Most of them you're not going to need at all, unless obviously you've got a radio controlled car or anything like that that you might want to use these to charge with. Please do be careful though. This here can be used to power the charger from a car battery, although I wouldn't recommend it in this case. Here we've got your actual power supply body itself. Just unbox this here. So what we've got here is a 15 volt 6 amp power supply, which is more than enough to power this charger. And we've got the Australian insulated power plug, which is perfect. So I'm going to plug this in here. Make sure that it's not turned on. Here we've got the instruction manual. Suggest you have a quick flick, but I'll show you the basic menus that you need to know. And then here we have the actual charger itself. It's a quite tidy little unit. Okay, so what we'll do here is on the left hand end of the charger we've got this DC in jack, so we're going to plug the power supply into that. Don't turn it on yet though. On the other end we need to get this little XT30 yellow plug going to 2 banana connectors. This should have been included in your kit. I'm going to open that up. This is very critical here You must plug the black wire into the black slot and the red wire into the red slot. If you do it the other way, the charger will fry. Now I'm just going to turn on this charger and we'll see what happens. So it powers up. We've got LiPo charge set to 2S at 1 amp. So this is important, and this is where you need to be very careful and follow instructions closely, as LiPo batteries can be a little bit dangerous if they're not looked after correctly. So I'm just going to put this down. So here we've got two different batteries. What you get could be either of these. I'm going to test both of them and see what's most suitable. So both of them are a 650 milliamp hour, and both of them are a 70C rating. But this one here is a 3S, which means it's got 3 cells, and this one here is a 4S, which means it's got 4 cells. If you don't have a label on the battery, the best way to check is actually by this little balance lead. So if you have a look, the 3S one only has 4 wires, and the 4S one has 5 wires. And the reason for that is you have a ground wire and then a positive wire going to each cell so that they can be individually balanced by the charger. So just as an example, let's take this 4S battery and we'll set it up to be charged. So the first thing you want to do is get this balance lead here and plug it into the charger. So you've got a bunch of pins and plugs in this white area, and each of these is for a different cell rating. So this is 2 cell, 3 cell, 4 cell, 5 cell, and even 6 cell. So what we have here is a 4 cell, so we're going to go to one with 5 pins and plug it in. There we go. And then we plug in the XT30 to the XT30. That's pretty simple, and it can't be plugged in backwards. Okay. Now that the battery's plugged in, let's look at the charger settings. So these are a lithium polymer battery, which is LiPo. If you decide to charge another type of battery, you'll want to go back. And so there's a bunch of different battery types here. So we've got PB battery, which is lead acid. That's like a common car battery. So if your car battery went flat, you could actually hook it up and charge your car battery. We've got NICD, which is NiCad, often used in older RC models. NIMH, which is very much like NiCad. And then lithium polymer. There is also a lithium ion setting hidden in here, but we aren't going to be using that for now. If anyone needs to know how to use that, just read the manual. I'm sure you can figure it out. So we're going to press enter and select LiPo battery. Okay, so now that we're in the LiPo charge menu, we want to set this for 4S firstly. So let's press the start button, just tap it again, and so this is now flashing, so we can press up, 3S and 4S. Press the start button again to exit the menu. And because this is a 650 milliamp hour battery, charging it at 1C or 1 charge rate, which is C rating is the amps in milliamp hours. So 1C would be a charge rating for this battery of 0.65 amps. Now we only have choices of 0.1, so we're going to go to 0.6 amps. There we go, so we set at 0.6 amps. Now the maximum I would recommend that you charge your lithium polymer battery at is 2C, and that's only if you really need it charged quickly. Anything over that and you're risking the possibility of the battery becoming unstable and puffing, and in worst case scenario exploding, but that's very, very unlikely. So now I'm going to hold the start button, battery check, and it's saying you've got a 4 cell connected and you've set it at 4 cell. So you want to press start and the charging will now start, and we'll just let this run its course and it will tell us when it's done. Then once it's done, it will beep and tell us how many milliamp hours and how much time it took. we'll press stop and unplug the battery, and then you can repeat for any other batteries that you might want to charge if you've got multiple, or next time you need to charge it back up. Okay, while that's charging, let's look at your hand controller. For this, we've chosen the FSI6. It's an older model, but we can actually custom modify the firmware, which is a great exercise, and it enables us a lot of extra features that you wouldn't expect a radio like this to have. Retail for this is only about $50, which is great. So let's open it up. You might need some AA batteries for this part. Don't think there's any included. So the box doesn't have much in it. We've just got a little user manual here. You can refer to that if you need, but I should tell you everything that's required. So here we've got the radio. It's a bare bones radio. It doesn't really have much features, but it has all of the necessary things that we need. You've got 1, 2, 3, 4 switches, 2 dials that you could use for gimbal control or something like that, and then your standard axis of sticks. So this is a mode 2 radio, which means throttle is on the left hand stick. Mode 1 is throttle on the right hand stick. There is also mode 3 and 4, which are variants of left hand and right hand stick throttle with different pitch and yaw and roll mixes. So this radio can actually do quite a lot, and you'll see that very soon, but for now we're just going to chuck some batteries in and fire it up. So it just takes 4 AA batteries in the back here. I've got some that I picked up at Aldi. Try to make sure that we include some in the kit. Okay, batteries in. Now, what we'll do is we'll pull up on this power switch, and we see that we've got power, and it boots up. An interesting thing to note is if we move the throttle up and flick a switch and try and power it up, it will say switches are in the incorrect position. This is a safety feature so that if it's in an armed position with the throttle up and an arm switch on, when you turn on your radio, your quad won't fly away like crazy. It's a good safety feature to have. Now on the back here there is an old school S-video port. So we can make a wire for this or buy a wire for this to go to a USB simulator controller, or you can actually plug it into your sound card of your computer and use this controller as a simulator. But what we can also do is connect our gear quad, the Tyro here, to the computer with USB, and using Betaflight we can actually use the wireless receiver in this as a simulator connection, and then you can use this controller to fly your simulator. This is really great and helps out for learning how to fly heaps, especially with these type of drones. We like to prefer to fly in acro mode eventually, because it makes them a lot more capable and a lot more powerful, and hopefully you'll learn that one day or soon, or if you haven't already. So now that we've got this radio out, we might actually look at doing some binding. So for the purpose of this, I'm actually going to take this top plate back off. It'll just make things easier, and it's only 4 screws, which is a great advantage of this little unit. Now because we've got the camera on, we're just going to feed through this VTX antenna and fold things over, and the camera just stays in there and we'll be able to fold that back. I'm just going to fold these camera wires down because when I noticed it was together, they were just touching on a few things there. So we look at this stack here. On the bottom of this receiver, we've got a teeny tiny little bind button on the underneath edge. Right there. And I'll chuck an image on the screen of where that bind button is, but I can just press that with my fingernail through the heat shrink. So what we need to do is we need to boot up the transmitter in bind mode. Here, this one. And we do that by holding the bind button and turning it on. And it should say RX binding on the screen. Now, while that's in bind mode, we need to hold down the button on here and plug in a battery. So I'll grab a battery that I've got sitting here. Okay, so we're in bind mode here. I'm going to hold down the little button on this receiver And we're going to power this up. And RX binding has turned off on the screen there. I'm going to turn that off, unplug this, turn the radio back on. If we power this back up, we get voltage readouts come up on the screen. This is an indicator that the bind is successful. Just to show you that, I'm going to unplug the quad and you'll see that they disappear. Okay, now that that's bound, we can turn the radio back off and we're going to reassemble this quad because we don't need to touch anything on the inside of here again. It should be ready to fly now with that section. We just need to do the setup on the computer. Okay, that's all back together. Okay, for this next part, you're going to need a USB to USB micro cable, much like this one. Length doesn't really matter, as long as it's got charge wires. We might try and include one of these in the kit as well. So this plug here has to plug into the side of your flight controller, right there. Make sure you get it the right way around. So we'll just plug that in, and then I'll show you the next part of this tutorial on a screen recording. We're going to do everything in Betaflight, and I'll let you know when I unplug and plug in this cable to my computer. And also we will need a battery. Something that's fully charged would be good, and I'll let you know when we unplug and plug in this from the quad. Please note, don't run any propellers on it yet. I know it's exciting to put them on. You can put them on and look at it, but make sure you do take them off for this step, because it is quite common that you will need to both spin up the motors, and it is possible that they will spin up without your consent, and that can be quite dangerous if the quad decides to take off randomly. Okay, so for the next portion of this video, we're going to be going through the actual setup of the flight controller and ESC for this quad. So first off, we're going to need some software. So here on the computer we've got Beetle Heli Configurator website, Betaflight Configurator website, and then the Impulse RC downloads page. I'll explain that soon. So we need Betaflight Configurator because on this flight controller we're going to run Betaflight software. It's the best for any type of drone like this. I actually run it on quite a large drone as well. And you want to come down here and pick the Betaflight Configurator installer, win32.exe. Obviously if you've got a Mac, you'll pick the Mac OS one, but I'm running Windows 10. So you'll download that and install it. And then the next one we will need is Beetle Heli Configurator. And same again, we need to come down here and get Beetle Heli Configurator Win32 or Win64. Win32 should work on most machines. If it doesn't, try out the Win64 one and just download that too. And then over here on the Impulse RC website, what you might need, and I'll cover this later, but is the Impulse RC driver fixer, which is this link just here. I'll cover that later, but with some flight controllers and some computers there is a driver conflict, and this driver fixer basically just fixes that right up and saves you having to mess around for a few hours trying to get things working. So once you've got all of this stuff installed and saved in a good spot on your computer, we'll go to the next part. Okay, so I've just double clicked and opened up Betaflight after it's installed, and you should see this screen. Now in the extracted folder of the Beetle Heli Configurator, we've got this Beetle Heli Configurator.exe. You'll want to open that up as well. We'll just leave that open in the background for now, but we won't need it right away. Okay, so this comes the time to plug in your drone flight controller to the USB port of your computer. At this point we don't want the LiPo battery plugged into the drone. So let's plug it in. I'm just going to plug it into the USB port here, and you'll see up this top corner here where it says manual selection, we'll get a COM port come up. So plug it in, and COM port comes up and it connects. It auto connects with this new feature. I've got that disabled at the moment actually. So we connect and we get to this main screen. Now if I pick up the quad and move it around, we can see that this little drone moves. So what you want to do straight away is pick up your quad, tilt it forward and see if it tilts forward with the arrow being at the front. This just checks that your flight controller board alignment is correct. If you put in the board sideways or not with the arrow pointing to the front, what can happen is that the quad can actually move to the side when you tip it forwards. This can be quite problematic because when you're on the quad it will flip out because it will auto-correct itself in the wrong way. So moving down to the ports tab, we can see that Serial RX has already been turned on for UART1. That means that the receiver that we hooked up, the Fly 14 Plus, default should be hooked to there. But first thing we're going to do is actually go down to the CLI, which is the command line interface, and also note that up here I've got Enable Expert Mode turned on. That just gives us a few more options down here on the left. And in this CLI, we're just going to write version and then press enter. And it says here, we've got Betaflight installed on a Maytech F411 flight controller. That's a target. And the version is 3.5.1 from September 2018. This is actually a pretty reliable version, and we're going to set it up on this version for now. In the future I'll go over how to update it, because in the last few weeks we've actually moved on to Betaflight 4.0 and we're up to 4.0.2 at the moment. And Betaflight 4.0 adds a lot of features, but it is also a lot more complex, and we're having some issues lately with, especially with smaller drones like this, with the flight controller being a little bit unstable. So we're just going to wait for that to become a bit more stable there as they develop the new release before we upgrade everyone. So if we go to the configuration tab, sorry, I just bumped it there. If we go to the configuration tab here, we can see ESC is motor features, DShot600 is selected. This is the ESC protocol. So traditionally ESCs run off of a PWM PWM, which is an analog signal, and it basically has a range that goes from 0 to 1000, and that tells the motor how fast to spin. But this has a pretty low refresh rate, and you also do get a bit of interference, and it lacks a lot of other features. Like for instance, with these ESCs, we can reprogram them over the one signal wire. So what DShot600 does is it actually uses a digital signal, and it can send data over that wire. And this actually this makes things a lot faster, and it makes the ESC respond a lot better, which when you're working with a flight controller is very important. Now if we scroll down here, this receiver section is linking back to the Serial RX being turned on in the ports tab. So we've got the receiver hooked up to UART1 on the flight controller, which is an input in the flight controller. So then in the configuration tab, this receiver area here is specifying what protocol we're going to use on that UART. So it's already selected as a serial based receiver. Generally when you start out it's on PPM, but because this quad comes pre-set up with some stuff, it will already be on serial based. And it's set to S-Bus, but we're actually going to use I-Bus with this. It has a little bit better latency, and we don't have to use the inverter on the flight controller. So we'll select I-Bus there. Everything else in here should be pretty right. Now that we've selected that, we're going to press save and reboot. And now we're going to connect. Now, when this flight controller is powered over USB, the 5 volt actually goes through to the receiver. So the receiver should be powered up from our laptop. So if we turn on our FlySky radio, we can see that there's actually a TX voltage showing up. This means that we have a connection. So if we go on here down to the receiver tab, and what do you know, our receiver is working. So I'm going to move the sticks on the controller, and you can see that we're getting movement here. So this is a good time to check that everything is working. So here on the controller you can see what I'm moving. So I'm going to move up on the throttle and the throttle moves up. Yaw, left and right. Pitch, up and down. And roll, left and right. So you should be able to see that the little quad down here on the screen is moving the way that we want it to. If it's not, you might want to check this channel map. By changing this channel map, AETR1234 is the default for FrySky, and that changes your roll, pitch, yaw and throttle axes. If you, for say, had got a Mode 2 controller and changed inside of it to make it a Mode 1 controller, then this would be wrong. So the next thing that we need to set up is the modes. So this is actually going to require a bit of detailed setup on the radio. Okay, so here we have the i6 controller, and you want to start with it turned off, and we're going to set up some auxiliary switches here, which is pretty much the only thing we need to set up at this point before we do a firmware upgrade. So let's hold these two in and power it on. You want to hold the OK button and go in up and into function setup. Then we can go down to auxiliary channels. Now these are currently set to VRA and VRB, which are these dials. I want to set mine to switch A and switch C. That's switch A for arm on and off, and switch C for flight modes. So here we'll go up on channel 5 until we get to switch A, press OK. Channel 6 we're going to go up to switch C, and then we want to long press the cancel button to save it. Press OK. The changes have kept. For now we're just going to leave it at this. We will do some more advanced setup in this radio when we go through the custom firmware, but that does take a little bit of extra work. Okay, so now that we've set up the auxiliary channels on the radio, we can see our 4 normal channels are moving. Then switch A switches auxiliary 1, and switch C switches auxiliary 2. You can also see auxiliary 10 is actually our RSSI reading. Now that is the default setup from the Fly 14 receiver that we have. So what we're going to do is up here select RSSI channel to auxiliary 10, and then we're going to save. The next thing we need to do is come down to modes. Here is where we're going to set up our arm and angle modes. Now this is already pre-set up when the quad comes, but we're going to delete these. So just press the little X here. In a fresh Betaflight install, you wouldn't have any of them set up. Now we're going to press add range on arm, and see here this channel selection has gone to auto, and now it's at auxiliary 10 because the RSSI changed. I'm just going to set this back to auto. Now what we need to do is move switch A, and see it auto selects to auxiliary 1. And see this little yellow piece here? When I switch the switch, it moves. So when the switch is down, I want the quad to be armed. So I'm going to move this slider so that it encompasses only that area, like so. So when the switch is there, it's armed. When the switch is down here, it's not armed. I'm going to save that. Now, on our other switch, we have 3 flight modes. Acro, which is quite advanced, and you'll have to figure out, it takes a little bit of learning to fly, but it gives you a lot more capability. And then we have horizon mode and angle mode. Now angle mode is pretty much full controlled flight by the flight controller. It's much like flying a DJI style drone, but without GPS lock, obviously. And then horizon mode still enables you to do things like flips, rolls, but when you send the sticks back to the center, the quad brings itself back to level automatically. This doesn't happen in acro mode. The quad just holds attitude. I find that flying in acro is much more like flying an actual aircraft, and it's very good for FPV. But if we're just flying line of sight, you probably want to stick to angle and horizon. Now I'm going to stick acro at the top of the stick for me, the top of the switch, because I use it the most. But you might like to switch angle at the top of the switch and horizon in the middle, and acro at the bottom. So when nothing is selected with this switch, we're actually defaulting to acro mode. So then we want to put the switch to the middle for horizon mode for me. So I'm going to press add range here, and I'm going to switch the switch to the middle. And we can see that it's auto-selected auxiliary 2, and we're going to move this slider in. Now we're going to go to angle mode up here, add range, set it to the third spot, and we're going to move the slider again. Now you'll notice after I press save, angle mode has lit up. So when I flick the switch back to horizon mode lights up. So that means that the flight modes are perfectly set up. The next thing that we need to set up is the motors, and don't worry, we're almost done. So in the motors tab you want to be careful. This is where it really matters if you have your props on. You do not want them on. So we're going to tick this little box here that says I understand the risks, and we just want to give it a very quick blip of the throttle and see if the motors spin up. But before we can do that, we actually need to plug in the battery. So I'm going to plug in a battery here. So I'm just going to give it a quick go. We don't want to leave the motors spinning at very low throttle for long because that can actually cause them to burn out. And we can see there all of our motors spin. Now what we need to do is one by one, so we'll start with motor 1, go around and see which direction they spin. The best way to remember it is that the props need to spin towards the front and towards the back of the quad. This means that the front motors spin like this and the back motors spin like this. You can also look at the diagram on your Betaflight screen. That's right here. So we're going to start with motor 1, which should spin clockwise. So we're going to spin it up, and I'm just going to put my finger on it, the bell, and feel. And it seems to be going in the right direction. Now we're going to go to number 2, which should be spinning anti-clockwise. And it's spinning in the same direction as motor 1, which is wrong. So motor 2 needs to be reversed. Now we're going to go to number 3, which also needs to be spinning anti-clockwise. And it's also spinning in the wrong direction. Now I'm going to go to number 4, and it should be spinning clockwise again. And it's spinning right. So this means that we need to reverse the direction of motors 2 and 3. So what I'm going to do is unplug the battery, and now we're going to disconnect from Betaflight. So we're done in here. And we're going to go to BL Heli Configurator. So I'm going to press connect. Remember, leave the battery unplugged at this point. We're going to press, so once we've connected, we then need to plug in the battery. So plug it in. Notice that the ESC doesn't do the rest of its beep. Now we press read setup, and we've got a lot of information about our ESCs and motors here. So this is where we can change motor timings, we can change all sorts of settings to adjust how the quad flies, but generally speaking these ESCs are quite good for what we're using them for. So all we need to do here is change motor direction for 2 and 3 to reversed. We can also change the beacon delay. So what the beacon does is it makes the motors make a beeping sound after 10 minutes of no activity with the ESCs powered up. This can be handy if you lose your quad and you can't find it, it will then start beeping. I normally change this down to 5 minutes, but for this one I'm going to leave it at 10. Now we can press right setup, and that is done. So now I'm going to disconnect, and as soon as I disconnect you'll hear the ESCs boot up. Now we're going to go back to Betaflight, press connect, and go into motors, and again retest our motor direction. So we're going to go number 2, which should be spinning anti-clockwise, and now it's spinning in the right direction. Number 3, which should also be spinning anti-clockwise, now it's also going in the right direction. So that's all of our motors set up. The last thing that we need to set up is actually our fail-safe. What we'll do now is we'll unplug the quad and we'll disconnect. Okay, so we've got our radio here and we want to set the failsafe. So we long press the OK button, go into System, down to RX Setup, and then failsafe. Notice all the channels are off. Since I put the ARM switch on channel 5, I'm going to go in and turn that to on. Now we notice that when it's set to -100%, which is when the switch is in the off position. That means that in a fail-safe condition, the quad will just disarm. So we're going to long press cancel and long press cancel again. This should successfully set the fail-safe so that it won't hurt or injure anyone or the drone itself when it loses signal. Okay, now that we've finished all the setup on the computer, we're actually going to check that our fail-safe works. So I've got the radio here and the drone, so I'm going to plug it in. Okay, it seems to be good. We've got signal on the radio, so we're going to test our ARM switch, and everything spins up. Here we can double check our motor direction again, and we're all good. So now that the quad's armed, you can see the throttle works, so we're going to test our failsafe. We're going to do this by pulling the batteries out of the controller. Physically turning the controller off doesn't work. So we're going to pull a battery out, and we disarm. So this replicates the signal actually running out and our quad in a fail-safe condition. This means that the fail-safe is working correctly and we don't have to worry about it from now on. Now, at this point, we're ready to actually give the quad a test fly. So what we're going to do is we're going to put the props on. So I'm just going to take all the bolts off. Oh, sorry, the nuts. At the moment, I only have the yellow props that are included with the Tyro79. I've got the proper ones on order. These props are not very good. The actual props that will be included in your kit are much better. But you want to think about the prop direction the same as the way that we actually think about the motor direction. So the props spin the same way that the motors do, and they spin going into the back and into the front of the quad. So when you look at the pitch on your propeller, if you spin it here, with the pitch forwards, it should go into the back of the quad, and the same with this way, because obviously these propellers are counter-rotating. So I'm just going to put those nuts on there loosely. Another way to tell is by the little arrows on the top of the props. And there we go. Now, doing up these props can be quite a problem. You need to do them up quite tight, and being a nylock nut can actually make this troublesome. We'll try and sort out a way. I used to use pliers, they work perfectly fine. I actually have a proper ratchet now. You might have one. If you do, go use it. So we're going to screw this on. So you want to hold the prop and the motor until it touches, and then what you want to do is pick the quad up sideways, put 2 fingers around the props. You can use a rag if you've got soft fingers, and then just torque it up a little bit, and you should not be able to hold the motor and turn the prop. I actually just bent that one. These props are not very good. The proper props won't be able to bend like that. Okay, there you go, you've got all the props on. One last thing is the battery strap. Now, I've already put this on. All you need to do is put it with the fluffy side up and poke it between the ESC and the bottom of the frame. I think I may have actually already covered this. Now, when we put our battery on, you'll notice that it actually goes over where these screws are. So we need to put some sort of pad. Now the Tyro comes with a few pads. These ones here seem far too big. We might be able to use them on the arms or something as a spacer. I'm not a fan of that. Actually, here you go. These pads are made for the bottom of this battery plate. That makes complete sense. So the other pad that we've got here is this guy. And I presume it's meant to fit down the middle here, but it doesn't. So I'm just going to grab some scissors and cut it to fit. Okay, so we might need to include a little bit of a thicker pad. This one doesn't quite clear the screws, but it's close enough for now. So what I'm going to do here is I'm going to poke the balance lead of the battery between the battery leads so that it doesn't flick around. And then we're going to strap the battery straight on the bottom. Now I think we will have included a longer battery strap. This one isn't not quite long enough. I'm going to steal one here off of another drone that I've got on my bench. This one's actually a little bit too long, but that's okay. Just poke in the excess at the top here. And there we have it. Now, I wouldn't recommend that you fly this inside or anything like that, but I'm just going to power mine up to make sure everything seems to be spinning okay. Place all the switches in the right spots. Plug it in at the back. And we're all good. Now I'm just going to arm it quickly. And it seems to be working great. Now I'm going to take it outside and we'll just do a very brief test flight to make sure it takes off okay. And you'll get to come and see that too. Okay, I'm going to switch it into angle mode so that it's easy to fly. Arm it, slowly bring up the throttle. And we've got a perfect little hover. So just to show you a quick glimpse of how crazy these things are. It is crazy fast.